Hi, my name is Jeremy Schulman. I'm Network Automaniac on Twitter. And in this tutorial, we are going to cover Python mocking for unit test coverage. And we are going to use PyCharm as our IDE because it's going to make it easy. So I'm going to start this from start to finish, beginning with a brand new project. So with PyCharm, I'm just going to click New Project. And here I'm going to call this tutorial mocking. And what PyCharm will do for us is it'll automatically create a virtualized environment. I'm using Python 3.8. It will even create a helpful little hello world script. So I'm just going to click create here. And while that comes up, I am going to wait for that. Okay, excellent. So by default, PyCharm creates this nice little hello world program. If I click the play button, what we're going to see is it says, "Hi PyCharm, just ran this program." It's just a nice way to know that your editor is all set up and ready to go. So we're going to use pytest for our testing engine. And to do that, or to at least use it, I need to install the pytest package. So I'm going to go to my preference settings, and I'm going to go to my project interpreter. And what this is showing is that in my virtualized environment, I only have 2 packages installed, because that's what happens when you create a new one. And we're going to install pytest. So I'm just going to type in pytest here and click install package. And there we go. Okay, that's done. All right, so again, the goal for this tutorial is to talk about Python mocking. Why do we do it? What is it? And how to use it in applications for, say, network automation. So to begin, what I want to do is introduce just some of the core concepts and capabilities of mocking. And to do that, the first thing I want to do is I'm going to create a file. Let's see, I'm going to create a file. So new file. And I'm going to call this test hot dogs. All right, so the whole point of unit testing is to validate that your program works by testing sections of that program in an isolated manner. And generally, large programs have interdependencies with one another, meaning if I'm writing a network automation program, I'm probably going to want to try to talk to a device and interact with it. In the construct of unit testing, we want to mock out the fact that we have a device, pretend that we're getting information back from the device, and see that our program behaves correctly. So that's kind of the purpose of mocking. It's to create, it's a way to isolate areas of the code and create a mechanism to pretend that they exist when they don't. All right, so I'm going to get to that use case of mocking out a device at the end, but we're going to build up to it. So in this file called test_hotdogs, I'm going to make a function called test_hotdog. Now, what you'll see right away is that PyCharm puts a little play button here because PyCharm knows that this is a test file because it begins with test underscore, and this function begins with test underscore. And when you do that, it knows that it's a test case, and you can actually click play. It'll run that test case, and we can see that that test case has passed. Right? It doesn't do anything, but we can see that it passes. Now, if I have another function in here that doesn't begin with the word test, you can see that the play button does not exist. So and this is really a function of pytest. Pytest has pattern matching to know what is a test file and what is a test function. So that's the first thing that you kind of want to know. Get rid of that. And a test either passes or fails if it executes without an exception occurring. So in this case, the code did nothing. there was no exception, and it passed. But I could make another function called test bad hot dog, and I could say assert true is false. True is false, which we know that assertion is going to fail. So if I run it, we can see that we had an assertion failure. What this shows us is the output of all of that. And we can see here that this failed because true is false is not true. All right, so that has nothing to do with mocking. That just has to do with how PyCharm lets you run these tests, and you can see the output. All right, so let's make some code that we want to test. So I'm going to make a new piece of code, and I'm going to call this file hot dogs. And in this file, I'm going to make a function called eat a hot dog. All right, doesn't really do anything, but let's pass it hungry. And let's say hungry, we're going to pass it as an integer, and we're going to return back an integer. And let's just say for now, we're just going to return back the value. Okay, so that's not really very interesting, but let's just start with that. So if I was writing a piece of code and I wanted to test that my code was working, I might do something like this. Import hot dogs. So that's, I'm importing the module that I want to test. And then I could say hot dogs, eat a hot dog 10, result, and I would say assert result is equal to 10, because I know what my function is supposed to be doing. And it's supposed to be returning that value that I pass it. So here, if I hit play, sure enough, that passes as we expected. And obviously, if I put in a different value here and run that, I'm going to get a failure. And what's nice is it'll say, I expected 11, right? Because that's what I'm asserting. And what I actually got was 10, because that's what it came back with. And it shows me that, that assertion failed and my test case failed. Again, having nothing to do with mocking. All right. So let's say that, we have some code that uses eat a hot dog and we want to change its behavior. I'm going to start with just mocking eat a hot dog, just so you can kind of see the core mechanics of how a mock object works. And the process of mocking a piece of code happens in 2 steps. The first step is you need to create what's called a mock object. So that comes from a library that's built into Python. So I'm going to say from unit tests mock import mock. And mock is a class, and so we're going to use that to create an instance of a mock object. And I'm going to say mock dog, right? So what we want to do is we want to create a mock of this function, right? So we're going to call this function just like we did before, right? But now we want to change eat a hot dog. We want to, let's say that we wanted, just for the sake of argument, we wanted to make it return not what we passed it, but we want it to return like a value, a fixed value. So I could say I have a fake eat. I'm just going to call my mock fake eat. And now I'm going to create an instance of a mock object, and I'm going to set its return value to be 1. So what's going to happen is, what I want to have happen is I want that when I call eat a hot dog, I want its return value to be 1 instead of the value that I'm passing it. And I'm changing the behavior of the code because I'm inserting a mock into the code. Now, this by itself does not insert it, it just creates the mock. And so to insert this mock, to basically stand in for this function, we do something called monkey patching. And PyTest gives you the capability to do monkey patching with what's called a fixture in PyTest. So here's monkey patch. And what we're going to do with monkey patch is we're going to use it to do set attribute. So this is going to assign, we're going to use set attribute or set attr to assign fake eat into our module. So I'm going to say, I'm going to set hot dogs, which is a module, and that module has an attribute called eat a hot dog, because a module's attributes, anything that's in a module, like a function, is an attribute. And so I'm going to basically tell the hot dogs module that I'm going to change its attribute eat a hot dog, and now I'm going to use fake eat. So now any code that calls hot dogs eat a hot dog is no longer calling the function that's in that module. It's actually going to use this mock, right? And so if I did assert res equals 10, we know that that's going to fail, or at least that we believe that that's going to fail, because what should happen is we should get the value 1. And so we're going to run that test. And sure enough, we do get the result that I anticipated, right? We expected 10 because that's what we're comparing to. We actually got 1 because now when we call eat a hot dog, it's not returning what we pass it. It's returning what this mock object is doing. It's returning a 1. So this is a very simple example of how to create a mock, change the return value of a function, and assign that mock into the Python module so that it performs or behaves like this. Okay, so you're thinking, well, that's kind of interesting, but what's going on with this mock? So what I'm going to do is I'm going to put a breakpoint in the code here, and I clicked on this line, and you see that this little red symbol. That's a breakpoint in PyCharm, and what that allows us to do is stop the execution of the code and kind of look around. So I'm going to close this window, and in order to run a test and use the breakpoint, rather than clicking run, you click debug. So it's going to start up a debugger, and you can see that the code has stopped here. You can see that it's highlighted, and now we have these variables that we can look at. We can see that I have a variable called fake eat, and it shows, I'll make this a little bit bigger. I can't make it bigger. Well, hopefully you'll be able to see that. I might take a different approach, but what we can do here is I can look at what is the construct of this variable, and I can see that fakey has something called call args list, call count, called, right? These are the attributes of this fake eat variable. All right, that's what a debugger allows you to do. You can examine the variable and what's in it. So here I can see that this mock has something called call count, and it was called once. Now we know that's true because I call this function eat a hot dog. And we also can see that there's something called call args. And call args basically tells us what was passed to eat a hot dog. And what I did is I just passed the value 10. And you can see that here as args, right? Args says I was passed 10. So call args basically tells you what was the last invocation of this function and what was passed to that function, right? So call args tells you that. Now, if I had changed this, I'm going to let this resume and just run to completion. Or I'm going to hit stop. Okay. So let's say I change this to be hungry is equal to 10. So I'm using the keyword equals value. And I ran this again. So let's do that. And now when I look at fake eat and I look at call args, and now I see that under keyword args, I see the hungry is equal to 10, right? Because this is a dictionary, and this is saying I have a key called hungry and its value is 10. So, using a debugger like this is really nice because you can kind of put a breakpoint and see what's going on. And now I just want to, continue going here. Yeah, let me close this out and click run. And this tells me that my assertion failed, right? So if I just click run here and not the debugger, we can see that, this failed. All right. I'm going to try doing another way to show you the same kind of data. rather than using the debugger, because I can't make this window very big, I'm just going to use Breakpoint. So if I click run, it'll just stop there. And you can see now I can make this bigger. Okay. So let's do the same kind of examination. I could pretty print what are the attributes of this variable called fake eat. This looks a little bit better. Okay. So pretty print, PP is just pretty print for the debugger. And when you do dir on a variable, it shows you everything about that variable. So again, we have call args, called, call count, call args list. So I could say, you know, fake eat called, it's true, right? We can see that's true. We could say fake eat call args. We can see that it was called with a keyword value of hungry equals 10. And if I do fake eat call args kw args, you can see that it's, you know, hungry is 10. And if I do the same thing, fake eat call args hungry, you can see that it's 10, right? So let's say that you were writing some code and you wanted to validate that as a result of doing something, you know, a call happened the way that you expected it to. You could do something like assert fake eat, and in this case we can say call args kw args hungry is equal to 10. And if we run that, okay, let me close this, close that so it stops the detach process. Okay, and I'll just close this and run again. What we can see is that this passed, right? So this is just basically saying, you know, my mock object was called with a keyword argument hungry with the value of 10. Now, this may not seem very interesting because I am doing the patch, the monkey patching right here, but consider a case where we're going to patch a function that's very far down in the stack of code. You'll see where this comes into play when we mock out a network device. So I'm just showing you the mechanics of what a mock object is and some of the things that you can get out of a mock object. So changing the return value of a function is one thing that you can do, as I've shown you here. Now let's do another case where maybe we're going to call a function multiple times, and for each time that we call that function, we want to return a different value. So rather than returning a fixed value like 1, we want to return an ordered set of return values. So you might think we would do this. Let's make another mock function called many. And you would say, well, I want to return a list of values. Maybe the first one is 10, the second one is 20, the third is 1, and then 12. We do the same patch. That's called patching. Right? We're going to do that patch. And now we are going to make 4 calls. And I will just do return 1, and I'll just do this 4 times. Boom, 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 boom. Okay. So we can see what the call arguments are. Okay. And I'm going to just put a dummy variable here so I can stick a breakpoint. That's all. Okay. So now if I do run with debug, so we can kind of look at this, what we can see is that every one of those return values was the complete list. And that wasn't what we really wanted. We can see that R1 is a list and it has, you know, the same values each time. So setting the mock return value isn't what we want. What we want to do is use a different technique called a side effect. Okay, so there's 3 different use cases for side effect that I'm going to show you. The first one is using side effect to return a different value for each time that it's called. So now if I do, let's see, stop. All right, that's done. I'm going to close this window and let's run it again. Now you can see that these 4 values are different, right? The first value is 10, the second value is 20, 1, and 12, just as we expected. And what we can do now is if I look at my variable fake eat, and I now look at call args, right? You can see that the last call was hungry equals 4, right? But we also have this thing called call args list. And this shows us each and every time that that mock was invoked. So you can see that that mock was called 4 different times. And each time, you know, we passed it a different value for hungry. And we can see exactly, you know, the contents, you know, of this mock piece of data. Super helpful, right? We can see that this mock was called 4 times, right? We know that, right? We can see that it was called. A lot of interesting things in here. So this is one way to do a side effect to return, you know, going through an iterator, right? It's iterating through this list. Now, the next thing you might ask is, well, what happens if we, what happens if we try to consume more than what the list gives us? So I'm going to click stop here, close this out. Let's say I try to do a 5th take from eat a hot dog. All right, now there's only 4 entries here, so something bad is going to happen. Let's see what it is. So we're going to click run, and we can see that we did get an error. And the error that we get, if we scroll down here, is we get a stop iteration error. Now this is what you would expect if you're familiar with how iteration works in Python. You know, if you're going through a loop, if you're going through an iterator and you keep taking values from it, eventually when you reach the end, what happens is a stop iteration exception. So that's exactly what's happening here. So just be aware that if you're using a side effect to return values from a list, that you can only take as many as that iterator will provide. All right, so that's one way to use side effects or side effect. Let's go to the next one. Let's say that we want to dynamically change what the function returns, but we actually want to look at what is being passed to that function. So let's kind of copy and paste this here. So let's say I'm going to do doubler. So let's say that rather than returning the value that's provided, I want to return the value doubled, right? So now what I want to do is I want to say my side effect is equal to a function that is going to double the value that it's given. So I'm going to call this doubler, which doesn't exist yet, and that's why we see the squigglies. So I'm going to create that function, doubler. Now, the way this works is when the function is invoked, so we're going to put this here, invoke. I'm going to say hungry is equal to 10. What's going to happen is the mock is going to receive the same exact key value pairs or parameters or anything that you put here. So what you normally put in this function, you want to match the signature, what is called the signature of a function. And in our function, this eat a hot dog has, you know, it just takes one value, you know, hungry. So I'm going to flip back here. I'm just going to put the word, you know, hungry here, hungry. I could match it completely if I really was very specific about it, which is great. And what we're going to do is we're going to return hungry times 2. All right. So the net result of this is we would expect that result, assert, result is equal to 20. And we'll just run that. And sure enough, that works just fine. It does exactly what we want it to do. And if I put a breakpoint here, just so we could see this, and ran this with debug, what's going to happen is we'll hit that breakpoint, you can kind of see that I have this hungry parameter is 10, and then I'll just let it continue to go. So I'll just say continue, and then that will be done. Show this again. So we're done with that, and I will close this out. Okay, so that's the second use of side effects, is you can give it a function to call, and then what you choose to do in this function is entirely up to you, right? And then you can change the behavior of that function. The third type of function that side effect allows you to do is raise an exception. So let's say that there's a piece of code that you want to test, and you want a function to raise an exception because you have some other piece of code that needs to handle it. So we're going to copy this, and we will deal with value error. So let's say what we want to do is we want eat a hot dog to cause a value error, right? So what we do is we just say, I want you to cause a value error. We'll call it, put whatever we want here, too much. All right, so what's going to happen now is when I call eat a hot dog, I'm going to get a value error. It's going to raise a value error. So if I tried this, hot dogs eat a hot dog 10, what is going to happen is it's going to cause a value error, and this test case will fail, because when a test case has an exception, it fails. And we see that if I scroll all the way down to the bottom here, we can see value error too much. Now, if you're writing code and your code generates an exception and it wasn't expected, then your test case fails and you would fix your code. But what happens when you want to test this exact scenario of validating code causes an exception? Well, what you do is you have to instrument your test case to catch that error and to expect it. And the way that you do this is through pytest. So we will import pytest. And we're going to call this piece of code, but we're going to do it in a way that tells pytest to expect and catch this exception. Now, what I'm about to show you has nothing to do with mocking, but I think it's very important for unit testing, and they're kind of related, so I'll show you this. So you say with pytest raises, and you tell it the exception or exceptions that you're expecting to happen, and then anything that happens inside this block of code, if this exception happens, then it doesn't cause the test case to fail. So now if I ran this test case, you can see that it passes, because a value error did occur. We expected it. Well, what happens if I put a different error in here? Let's say that I expect a runtime error, but now we know that eat a hot dog actually causes a value error. So now if we run this, our test case fails because we got the wrong kind of exception. Right? Let's scroll down here. We can see, again, value error too much. Okay, well, what if you want to capture, the actual exception because you want to look at it for some reason? Well, you can do that by adding this mechanism at the end. So with pytest raises value error as exception info. So what I'm doing is I'm saying when this happens, store the result into a variable of my naming. I choose to use the name exec info, and because I want to look at it. Right? And I want to examine what exec info is. So I'm going to just put a dummy statement here so I can set a breakpoint, and we'll look at it. We'll close this off, and we're going to click debug, let this run. Okay, so this happened, and now I have this variable called exception info, right? And you can right away you can kind of see what's going on in it. You can see that it captured a value error, and you can see its data. So if I wanted to look at the attributes of this exec info, I can see that there is a value, and that value is the exception, right? So I can see that it has that value. If I click into it, I can see it has arguments. I can see that the arguments, is a list or really a tuple, and the first parameter is too much. So if I wanted to capture an exception and validate that I got the exception and validate contents of that exception, I could do something like this. I could say actual exception is exec info value, and I could say assert that the actual exec args 0, which is the message, basically has some string in it. Like I could look for too much specifically. I'll remove that breakpoint and close this out. Get rid of this line of code. So now I've captured the exception, and now I could run my test. My test passes because not only did I get the value error, but the content of my exception matched what I expected, right? Well, what if you wanted to kind of combine the two things that we just learned? Like maybe I want to put information about what happened, not so much in the string, but something about that side effect. So let's do the same trick where we define a function called bad thing happened, and it takes our parameter. I really don't care what our parameter is, so in this case I'm just going to ignore the parameters that are provided, right, for eat a hot dog, because I don't care that, I don't really care what I pass it. In this case, I just want to raise an exception. Actually, I take that back. Let's do this. Let's put this back, hungry. And let's say value error, and I'm going to say too hungry, and I'm going to actually put the value in there, hungry. All right, so now my exception will contain something about the data, which is kind of cool. So I'll change this, and I'll change this to bad thing. And now let's just put a breakpoint here so we can see what's going on. We know that this is actually kind of fail. So let's close this and run it in debug mode. Okay, so now we're here, and we can see that my exec info has a value, and that value has the data in it, right? And you can get as creative as you want, or if you're writing code that has different types of exceptions, you can pack as much data as you want in there. But I'm going to stop on this tangent because I think I've covered more than I actually meant to. So, but the point is the side effect mechanism of a mock allows you to do different things depending on what you need it to do. So hopefully that covered the kind of the core functionality of mocks using side effects or the return value. Okay, so now let's do something that's more interesting and specific to network automation. Using what we've learned here, what I want to do is use the napalm library to validate how it handles one of its functions. For example, the give me the ARP table information. So we're done with testing hot dogs. We can kind of close this out. And what I want to do is I want to install the napalm library. So again, I'm going to go to my Python interpreter, and this time I'm going to install napalm. Boink. Install package. And I'm going to fake out, say, just kind of an iOS device. So I have, an iOS device in my network, and what the napalm does, which is really nice, is it gives us an abstraction for devices. So let's make a new file, and we're going to call this test file test napalm. Right. So I'm going to say import napalm and test fake device, and normally you would do something like this. Driver is napalm get, say I want an iOS, and then I'm going to have some fake device, which is this driver type, And the host name doesn't matter because it's fake. And the username doesn't matter because it's fake. It's all fake. Password is nope, because it's all fake. You know, we're not doing anything. So this is now what this is going to do is this will create an actual Napalm, you know, device driver. I'm not doing anything with it, but it creates an instance of that object. And if I tried to open it, you know, this would fail because, you know, this is not a valid host name or anything like that. If I wanted to fake out, you know, the open call so that if some piece of code did call open, well, we could go back and we would create a mock. So from unit test mock, import mock. All right, so in this case, I'm just creating a mock object. Now, if I did call open, and then I said assert, you know, fake dev open called, it's gonna pass. Now, when you look at this, you're like, this is silly. Like, why would you ever write a test case like this? You generally don't, but the idea is you can make a mock object, then you would call some piece of code which could eventually call open, and then you can see whether or not the code did call open or not. I'm just putting it straight in line because I don't want to create an entire, you know, framework of code just to show you a concept. But I will put a breakpoint here and we'll run through this so you can see the mechanics of it. All right, so we hit the driver. So this driver, we can see, is an actual Napalm iOS driver class as we expect it to be, right? So now I'm going to step over this piece of code. And in my fake driver, if I scroll down to the open function, you can see that it's a mock, right? Whereas all these other functions and capabilities of this object are as they should be because, you know, I haven't messed with them. And now if I step over this piece of code and execute it, you know, I've called the function. And if I look at fake dev and we look at open and we look at this mock object, we can see exactly what's happened, right? Call args, or call count was 1, call was true. And if I let this continue to go, just resume program, you know, we're done, right? So everything, you know, worked accordingly. Everything is pretty copacetic. Close that out. So let's kind of take the next step of this. Like, I don't want to mock open. This is not really important. But what I do want to do is I want to run the get ARP table function. Okay. So the goal here is I want to test get ARP table for an iOS device, but I want to control the content. I want to control the CLI output that this function is going to parse. Now, I don't know, let's say I don't know how Napalm works under the hood, right? So I'm just going to run this piece of code and watch it blow up and see where it blows up. And this is how I do this. I'm going to click run. It's going to blow up because there is no device. And this is going to tell me exactly where it blew up, which is super handy. So it says, hey, this blew up in this function get ARP table. So I'm going to just click on this link and it's going to take me to that code. And I see that this code is here. No, let me go to this code. Sorry, you should go to the last exception. So I went to the last exception and I see that I'm in this function called send command. Right, I can see actually up here in my breadcrumb browser, I can see that I'm in this thing called send command. So if I wanted to mock out, you know, what's going on here, I know from looking at this that this function send command is going to actually go talk to the device, issue this command, and get some output back, which should be some string. Great. So I know that I want to mock send command. So that's what I'm going to do. I'm going to get back to this. I'm going to close this out. I'm going to say fake dev send command is going to be a mock. And the side effect is going to be give fake data, right? So now we have to define a function called give fake data, which is going to take a command and it should return back a string. But we don't know what that string, let's say we didn't even know what the command was that napalm executed. So we're going to find out. We'll stick a breakpoint here. We'll click run with debug. Wait for it to stop. Boom. All right, done. We can see that the command that is passed is show arp pipe exclude incomplete. Okay, so now we know what we need to go to a device, run that command, and capture that output, stick it in a file, and then massage it to be whatever we want it to be. Because maybe we want to test like many different collections of data. Maybe we want to collect 10, 15 samples of data and run it through this parser and see what happens. So I'm going to just close this out. And what I'm going to do is I'm going to make a file that has fake data in it. So we'll call this fake CLI data output. And I'm going to put some data in there. So let's do that. Okay, so this is just some data that would come from a device, an iOS device specifically. And just stick it in a file, and I put the file there. So what we want to do now is we just want to do return open, and then this is going to be the fake CLI data out. We want to read the content of that data. Okay, so what this is doing is when this function is invoked, we're going to read data out of this file, and we're going to return that data, and then we're going to let napalm parse that as if it had gotten the data from the device, and then we're going to see what the result was. Now, what we expect the result to be is a list of dictionaries. Let's see if another thing that I really like about PyCharm is if you go to a function and you hit the shortcut for show me the internal documentation, I can just pop up the documentation for this function because the author did a very nice job of documenting this function. So I know exactly what's going on. Here's the function, returns back, he says it returns back any, but really we can see that it returns back a list of dictionaries. And so I know that in my case, because of my fake data, I have 2 entries, right? So I know that the length of my result should be 2. So I could say assert length of result is 2, for example. Let's see what else we've got. Now we also know what the key and values are. I can say, I can see what my interfaces are, my IP addresses and all that. So let's just stop here and we'll run through this and see if it gives us what we want. So I am going to actually put the breakpoint there, click run debug, let it run, and we'll wait for it to hit the debug or the breakpoint. And now we look at the result, and we can see the result is in fact 2 dictionaries, and we can see the dictionaries here. And look at the data even more. I can see that I got VLAN 12, I got this MAC address, I got this IP address, I got its age, and if I look at this data, that kind of matches up. Right, and if I wanted to, do this programmatically, I could. If I wanted to validate the parser, I could, using the data that's in here, validate that. So, for example, I could say assert res 0, and in this case, I know that the age should be equal to 11, because if I look at this data, I could say 11. Right, I know that it should be 11, and but what about when it's none? This is like there's no age here. So what does napalm do in that case? I can see that the age is not none. They set it to 0. So I can say res1 age is equal to 0. Now I'm using integers. It says that it's floats. I'm just curious to see if it works. Okay, so I'm gonna take out the breakpoint and close all this out. And I'm just gonna run this normally. And this says that it ran okay. What I'm getting here are, I'm seeing all these interesting warnings for what appear to be Interesting. These are depreciation warnings. So there's something in the code, in the Napalm code, that is triggering some depreciation warnings. There is a way to, I think, to turn that off and suppress it in PyTest. I don't know it offhand, and I'm not going to struggle with learning it, but I'm fairly certain there's a way to turn that off. But regardless, you can see that the test passed. Here we can see that this test passed. Okay, so that's about all I wanted to cover in this introduction. I wanted to demonstrate kind of a real-world network, automation kind of use case. So hopefully, the use of mock with side effects and pulling data from files was a helpful example. Again, we're just scratching the surface with mocking. There is just a vast, complex set of things that you can do with mocking, and if anybody would like to see more mocking and get more details on and some of the more intermediate level or advanced techniques, please put your questions in the comment section below this video, and be happy to answer them or shoot another tutorial. Thank you.